Hello students, welcome you to this session. So in this video, I am going to teach two-dimensional analytical geometry in which conic section we are going to study. So conics. Normally analytical geometry in the lower classes we start with distance formula, section formula, midpoint, then area of a triangle, right? Then slope, equation of straight line. Then 11th standard you would have studied pair of straight lines. Then here the first topic is circles. Okay, so now conics, it's entirely a different one. So you know what is locus? What is locus? It is a path traced by a point under some geometrical conditions, right? So there is a moving point and some conditions given. Under that condition, where and all it can move. So just join them, you will get a curve. And that curve we call it as what? Locus. So here, what is conic? Conic is also locus of a point. Here, S is a fixed point. S is a fixed point, and this line L is a fixed line. There is a fixed point and a fixed line. P is a moving point. I'm taking P as x comma y. P is a moving point. It can move anywhere under a condition. There is a condition. What is the condition? SP by PM is always a constant. So this ratio is a constant. SP by PM. What is SP? Distance from the fixed point. Fixed point to that moving point. That distance divided by, from that point you draw a perpendicular line to the fixed line. That is PM. So if you divide that to SP by PM, you have to get the same number. SP by PM is 1 by 2 means every time it should be 1 by 2. Such a way where and all it can move. That points you join, you will get a curve, and that curve we call it as what? Conic. And here we have some terms. Fixed point I said, right? S is a fixed point and that fixed point is called focus. The fixed point is called focus. There is a fixed line L and that fixed line is called directrix. And the ratio SP by PM equal to E, that E is called eccentricity. So focus, fixed point, directrix, fixed line, E is the eccentricity. There are different types of conics. So when this E changes, we get different curves, right? So when the eccentricity equal to 1, that conic we call it as parabola. When eccentricity is less than 1 means don't think it can be negative, no. It should be between what? 0 and 1 because ratio SP by PM, some distance by another distance, right? It cannot be negative. When eccentricity is less than 1, that conic we call it as ellipse. And when eccentricity is more than 1, that conic we call it as what? Hyperbola. So here they can frame one more question. Suppose eccentricity is root 3. Then what type of conic it is? You know the value of root 3, 1.732, right? 1.732, it is more than 1, so definitely it is a hyperbola. Okay, so using eccentricity, you can identify which type of conic it is. And sometimes they will give the general second degree equation. So we studied the general second degree equation as x square, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals 0. That's a general second degree equation. But if the equation is given in this form, ax square plus bxy plus cy square plus dx plus ey plus f equals 0. Order is same. X square, then xy, then y square, then x, y constant. Coefficients we take in order A, B, C, D, E, F. Not like the coefficient of x square is A, coefficient of y square is B, not like that. Okay. So first x square, xy, y square, x, y constant. Coefficients are A, B, C, D, E, F. If an equation is given like this, which type of conic it represents, if they ask, you identify the values of only A, B, C. In this case, what is A? Coefficient of x square. A is the coefficient of x square. B is the coefficient of xy. Don't take half of that and all. Coefficient of xy is B and y square coefficient is C. First you identify the values of A, B, C. So after identifying this A, B, C, you find B square minus 4AC. So it is a familiar term, right? So in quadratic equation for nature of roots, we find B square minus 4AC, right? So you find B square minus 4AC. Here we compare with 0. In eccentricity, we compare with 1, right? So here instead of 1, here you use 0, that's all. If it is equal to 0, it is a parabola. Less than 0, it is an ellipse. When it is more than 0, it is hyperbola. So there are 3 types of conics: parabola, ellipse and hyperbola. We are going to study one by one in detail. First, let us see parabola. So here, first I am going to teach how to derive the standard equation of parabola. Before that, I will give you some idea. So parabola, it will be like this. This is a parabola. In 10th standard, you would have studied the graph of a parabola, right? It is like this. Yes, that's a parabola. It can be like this also. It can be like this also. This is parabola. There are 4 types. We will study everything in detail. First, we are going to study about this one. This is the standard type parabola. So how to derive? Its standard equation of this parabola is y square equal to 4ax. The standard equation of this parabola is what? Y square equal to 4x. So let me explain a little fast and brief how to find the standard equation of parabola, and the proof also you have to study. Okay. So we draw a curve. Say these are the axis, x-axis and y-axis. This is O, and the parabola will be like this. So this is vertex and it moves like this. Okay, say this is a parabola. And there is a fixed point. So here, the fixed point, yes, here, same distance left side the fixed line. Because SP by PM is equal to 1 in parabola, right? So both the distance must be same. So this and this, here you take a point. And through that you draw a line. Through that you draw a line here. Okay, so that is the fixed line. So this is the fixed line L, fixed point, and this OS and this point I'm taking it as Z. So OS and OZ equal to A. And P is a moving point. So I'm taking the point P here. So P is a moving point. I'm taking the point as say XY. We take the point P as what? XY. XY is the moving point. And the condition, you know, SP. You join this SP by PM. From P, you draw a perpendicular line to directrix. SP by PM is equal to E. SP by PM is equal to E. But in this case, E is equal to what? 1. Can you say the coordinate of S? S is a point on x-axis, so its y coordinate will be 0. Y coordinate is 0. X coordinate is this distance. This distance is what? A. So now one more line I'm going to draw. From P, you draw a perpendicular line. From P, you draw a perpendicular line so that you know this distance is y and this distance is what? X. So that is why this point is what? X comma y. So this is the diagram. So what are the things necessary? You can draw and you can draw a neat diagram. So cross multiply, you are getting SP is equal to PM. Square it, SP square is equal to PM square. So let us find PM separately. PM is equal to NZ, right? Because from P we drawn a perpendicular. From M also there is a perpendicular. It looks like a rectangle only, no? So PM and NZ are same. So NZ can be written as sum of 2 terms. You write in terms of O. NZ can be written as OZ plus ON. OZ plus ON. What is OZ? OZ is same as what? A. Plus ON. ON is X, right? because P is the point xy, so ON is x. So that values you substitute SP square equal to PM square. How can you find SP square? Distance formula, right? S is the point A comma 0 and P is the point x comma y. So SP square means distance formula, but don't take root because SP square we take. So x minus A the whole square plus y minus 0, that is y only, y square equal to PM square. PM is A plus x the whole square. Now just expand it, A minus B the whole square type, right? So x square minus 2ax plus a square plus y square equal to the right side you square it, a plus b the whole square, a square plus 2ab, that is 2ax plus b square is x square. So both the sides you can cancel, x square you can cancel, right? So now a square also you can cancel. Left side you keep this y square, right side already you have 2ax, this minus 2ax take it to the right side plus 2ax. So y square equal to like terms, right? 2ax plus 2ax is what? 4ax. So y square equal to 4ax. So this is the proof of this one. But when you write for the examination, you write the steps also. So just will show that one how you are right. So you have to draw a diagram like this. Let S be the focus and L be the directrix. Only this one you have to remember. OS equal to OZ equal to A. So this O is called vertex. O is called vertex. Vertex to focus, vertex to directrix. Both the distances are equal and that distance we take it as what? A. So then S is the point A comma 0. P be a point on the parabola. Draw Pn perpendicular to x-axis. Then Pm equal to Nz. You can see the diagram. Pm and Nz are same, and that Nz can be written as Nz, this full distance, right? Nz can be written as the sum of On plus Oz, right? On plus Oz. So you are getting x plus a. Sp square, distance formula we are using. Then Sp by Pm equal to 1. Cross multiply Sp equal to Pm, square it, Sp square equal to Pm square. Just you substitute, you will get the answer. Okay, so this is y square equal to 4ax. It's a standard equation of parabola. But I said there are 4 types of parabola. So now let us see what are the 4 types of parabola. So this is the first type parabola. Standard equation we studied, y square is equal to 4ax. Y square equal to 4x. This point is the vertex. So vertex is 0, 0. Focus will be inside the curvature. Okay, so that is focus. S is here and directrix will be here, right? This is the first type. And this we call it as open rightward. This we call it as what? Open rightward. Now this is the second type, open leftward. Open leftward. And here the equation is y square equal to minus 4x. Just you can compare and study. Okay, so I'll give all the results. If you know the results of the first type, then you can easily remember the other results. So here the equation is y square equal to minus 4x. Only sign changes. Vertex remains same. This is the vertex. 0, 0 only. Focus will be inside the curvature. So focus is here. Directrix will be outside. Okay, so here the directrix will be there. But remember, these 2 distances are always what? Same. Okay, for parabola. And this is the third type. This is the third type parabola, open upward. The first one is open rightward, second open leftward, and the third one open upward, and the fourth one open downward. But the axis, if you see, for the first type and second type, x-axis, that is the axis here, right? X-axis, the curve is here, and this is the axis for that, okay? So, but for the third and fourth, the axis is what? Y-axis. The curve is symmetric about y-axis, okay? So, here the axis is y-axis. So, in the equation itself, there is a change. X become y and y become x. See the first type, y square equal to 4x. So, can you say the equation of third type, instead of x you put y and y you put x. So, the equation will be x square equal to 4ay, x square equal to 4ay. Then immediately you can say the fourth one, right? Similar one, but only sign you change. So what is the equation? X square equal to minus 4ay. Now itself already you studied so many results. Okay, so there are 4 types of parabola. Now I'm going to explain in detail the first type. Look at this. This is the first type parabola. This point is the vertex. So here the vertex is 0, 0. Vertex is what? 0, 0. Focus will be here. S is the focus. You know the coordinate. It is A, 0. Axis is x-axis. So equation of x-axis is what? Y equals 0. Sometimes they ask, find the axis of this parabola. So here the axis is x-axis and the equation y equal to 0. Then directrix, you know, directrix will be in the left side, right? Directrix will be the same distance, but it will be here. So this is directrix. We take it as say DD dash, directrix. So this point is minus A, right? So equation of directrix is x equal to minus A. All this we need. Equation of directrix is x equal to minus A. So remember, this is the first type parabola. What are the results we are studying here? First one, it is the name of this parabola. It is open rightward. It is open rightward. Its standard equation. What's the standard equation? Y square equal to 4ax. What is its vertex? 0, 0. What is its focus? Focus is A, 0. What is the equation of directrix? X equal to minus A. X equal to minus A. So these are some of the results. And I'm going to teach another very important result, that is lattice rectum. Lattice rectum. So definition of lattice rectum. What is lattice rectum? It is a line perpendicular focal chord. What is lattice rectum? Perpendicular focal chord. Same definition for ellipse and hyperbola also. So lattice rectum is a line. It is a perpendicular focal chord. Every term is important. You know what is chord? In circles you would study, right? Chord means it's a line joining any 2 points. So in parabola, what is lattice? What is chord? Just join any 2 points, it is a chord. How many chords you can draw? You can draw infinite number of chords. First you remember, lattice rectum is a chord. It is a line joining 2 points. But another condition. Let's go to the previous word. What is that? Focal chord. It is a chord and it passes through focus. So for parabola, you know there is a focus, right? S is a focus. You know the point, it is A, 0. Focal chord means it is a chord. You have to join 2 points of the parabola. And one more condition, it must pass through focus. How many such chords you can draw? Some of you are thinking only one, right? No. You can draw infinite number of focal chords, right? Infinite number of focal chords you can draw. But one more condition is there. What is the next condition? The previous word you see, perpendicular focal chord. What is that? It's a perpendicular focal chord. So that means, so it is a chord passing through focus. Also it is perpendicular. That means it is perpendicular to what? The axis. Axis is x-axis. So this line is called lattice rectum. So what is lattice rectum? Perpendicular focal chord. It's a chord passing through focus. Also it is perpendicular and we denote it as LL dash. Now I'm going to teach 2 or 3 very important results in lattice rectum. First, what is the definition of lattice rectum? We studied perpendicular focal chord. Now let us see what is the length of lattice rectum. What is the length of lattice rectum? So I'm taking SL as say Y1. Can you say the point L now? This distance is A. Vertex to focus, the distance is A, right? So L is a point, the coordinate is A, Y1. A, Y1. You know equation of parabola. What's the equation of parabola? Y square equal to 4ax. This point A, Y1 lies on the parabola. Lies on the parabola. So this point must satisfy the equation, right? So for y, you write y1. So y1 square is equal to 4a into x. X is also a. So that is 4a square. So y1 is equal to, take square root of this, you will get 2a. So y1 is 2a. So I want length of the lattice rectum. So therefore, length of the lattice rectum equal to, the length means the full length you should take, right? LL dash, the full length. So this part I had taken as y1, so that means this is also y1. So y1 plus y1, what is that? 2y1. So length of the lattice rectum is 2y1. That is 2 into y1, you got it. What is that? 2a. So 2 into 2a, it is what? 4a. So length of the lattice rectum. So this remains same for all the 4 types. There are 4 types of parabola. So this 4a is for all the 4 types. So length of the lattice rectum is always 4a. Okay, so this is one important result. So 2 things we studied. First, what is lattice rectum? What is its length? Now I am going to teach the end points of lattice rectum. End points of lattice rectum. The coordinate of L and the coordinate of L dash. Now already you know it's very simple one, right? L is the point. Can you say what is a comma y1? A is a only. Y1 value, got it. What is y1? 2a. So this is one end of the lattice rectum. Other end is L dash. That is, x coordinate is same, y coordinate same, y1 only, but it is in the 4th quadrant, so you have to take negative. So it is a comma minus 2a. So this is another important result. And the last result what I want to teach in lattice rectum is equation of lattice rectum. Equation of lattice rectum. Equation of directrix we study, right? Equation of here you take a point, say minus a, through that you draw a line. That is what? Directrix. So x equal to minus a. So here also is a line perpendicular parallel to y-axis. So x equal to constant only, and that constant is what? A. At a distance we are drawing a perpendicular, so it is x equal to a. So in lattice rectum, these are the 4 things you remember. First, what is lattice rectum? It is perpendicular focal chord. Then length of the lattice rectum for parabola, for ellipse and hyperbola, different formula, but definition remains same. So length of the lattice rectum is 4a. Length of semi-lattice rectum, sometime when you go for the exam, question will be like that. Semi-lattice rectum is half of that, so it is what? 2a, right? Then end points of the lattice rectum, a comma 2a and a comma minus 2a. Equation of lattice rectum, it is x equal to a. Okay, so these are the results you have to study. Now listen, for all the 4 types, the results what we studied, so we are going to compile everything. So that sums will be easy for you. That also, first I am going to teach, just recall the results of the first type only. You know, there are 4 types of parabola. You compare and study, it will be easy for you. So this is the first type parabola, second type, third type, and the 4th type. Listen, so first we are going to write results of the first type only. So the name, you know, what's the name of the first one? Open rightward, right? Second one open left. Third one open upward, open downward. 4th one. First one, what's the standard equation? Y square equal to 4ax. Y square equal to 4ax. What is this vertex? Vertex is at this point, right? It is 0, 0. What is his focus? Can you say focus will be inside this? Okay, so this is the focus. So what is focus? A, 0. Focus is A, 0. Equation of directrix. Directrix will be in the left side, right? So x equal to minus a. X equal to minus a. Length of the lattice rectum, it is 4a. And much more we studied, right? Okay, at least learn these things. Okay, first type you know everything. Now let us see how to write the other things. For the second one, standard equation, y square equal to minus 4ax. Third one, instead of x you put y and y you put x, right? So y square equal to minus 4ax. So here you write x square equal to 4ay. And the last one, x square equal to minus 4ay. Now the vertex, please listen, for all the 4 cases, the vertex remains same. So vertex is what? 0, 0. For all the 4 types, it is 0, 0 only. Focus, it changes. Please listen. See the focus. For the first type, the focus is here, right? A, 0. Second type, it is here, inside the curve only. So here, for the first type focus, second type focus, third type, the focus will be here. And the 4th type focus will be here. In x-axis, you know, y coordinate 0. In y-axis, x coordinate is 0, right? So for the first type, what is the focus? A, 0. Second type, it is minus a, 0. Third type, it is on y-axis, so 0, a. it is 0, comma a, and for the last one, it is 0, comma minus a. Now, equation of directrix. So, for the first one, directrix is here. So, this is the directrix. For the second type, directrix is here. For the third type, the directrix is here. For the fourth one, the directrix is here. So, the equation you can see, but the distance is what? A. The distance is what? A. Parallel to x-axis and parallel to y-axis for the first two, parallel to x-axis for the last two. So, here x equal to minus a. So, here second one x equal to a. Third one y equal to minus a, and the last one y equal to a. Length of the lattice rectum for all the four types, it is what? 4a only. Okay, so these are the results when the vertex is what? 0, comma 0. But when the vertex is not 0, 0, it is some other point, h, comma k, then how to write these results? Very simple thing. Next, we are going to see that. Okay, listen. If the vertex is not 0, 0, suppose the vertex is at h, comma k, some changes you have to make. So what changes, if you learn the results when the vertex is 0, comma 0, it is very easy only. For x value, you add one h, and y value add k. Instead of 0, 0, now it is what? H, comma k. So for x, 0 become what? H, and y, the 0 become what? K. So this one alone you remember, you can do it very easily. Okay. So now please listen here. Let us see for the first one. You know the standard equation. The standard equation is y square equal to 4ax, right? So here when you change x 4a, instead of x you write x minus h, and y you write y minus k. Okay, this is what you write. Vertex, for the when it is 0, comma 0, we write everything 0, comma 0, right? But here the vertex we taken as what? H, comma k. So it is not 0, comma 0, it is h, comma k. Okay, so this is another axis for this. Focus. For the 0, comma 0 case, the focus is what? A, comma 0, right? But now what I said, for x coordinate add h, y coordinate add k. So what you write? A plus h and 0 plus k. Okay, like that you remember. Equation of directrix. So earlier we written x equal to minus a, right? So now x is equal to minus a. Since it is x value, add h. That's all. Length of the lattice rectum always 4a only. Length of the lattice rectum is always 4a. Now see the second one, same equation, only thing instead of 4a you write what? Minus 4a into that you write. Okay. Then vertex is what? H, comma k only. Now listen the focus. Actually it is minus a, comma 0. But now we have to add h, k. X coordinate you add h, minus a plus h. Y coordinate add k, 0 plus k. It is what? K. And equation of directrix, it is x equal to a for the first type when the vertex is 0, comma 0. But here x value. So add h. So your answer is x equal to a plus h. And length of the lattice rectum is always what? 4a only for all these. Vertex is h, comma k. And now we see the equation for the third type when the vertex is h, comma k. Actual equation is x square equal to 4ay, right? But don't write x instead of x, x minus h, the whole square equal to 4a into don't write y, you write y minus k. For the fourth type, instead of plus 4a, you write minus 4a. Okay, that's the only change. Now please listen this focus for the first. When the focus is, when the vertex is 0, comma 0, we write 0, comma a and 0, comma minus a, right? But now, when the vertex is what? H, comma k. For x coordinate, you add h and y coordinate add k. So x coordinate add h, y coordinate add k, a plus k. So for the next one, it is 0 plus h and minus a plus k. You have to add k. Equation of directrix, when the vertex is 0, comma 0, it is y equal to minus a and y equal to plus a, right? But now the vertex is what? H, comma k. So for x value, add h. Y value, add k. This is y value, y equal to minus a. So you have to add k, minus a plus k. Here y equal to a plus k. Why we are adding k? Because it is y value. So remember h, comma k. For x, you add h. For y, you add k. So hope you understood all these things. So comparing this, so I given a table. So first, what I written in blue, that is when the vertex is what? 0, 0. What I given in red is when the vertex is what? H, k. So that's all the theory part. First, what is conic? There are three types of conics: parabola, ellipse, hyperbola. How to identify whether it is parabola or ellipse or hyperbola? Two types I taught. One is using eccentricity. Using eccentricity, when eccentricity is equal to 1 parabola, less than 1 ellipse, greater than 1 hyperbola. Another one, if the general second degree equation is given, you identify A, B, C. What is A? Coefficient of x square. What is B? Coefficient of xy. What is C? Coefficient of y square. You find B square minus 4AC. If it is equal to 0 parabola, less than 0 ellipse, greater than 0 hyperbola. Then we studied parabola in detail. How to derive the standard equation of parabola, y square equal 4x, the derivation important, you practice it. Then the results. When the vertex is 0, 0, one set of results. Then the vertex is h, k, another set of results. For all the four types parabola, no need to mug up anything. The first type alone you study. Once you know the first type, you see what changes you have to make. Okay. Then vertex with 0, 0 you study, h, k, what change you make. Because similar changes we are going to give for ellipse and hyperbola also. Then I taught lattice rectum we studied. It is perpendicular focal chord. Then length of the lattice rectum, semi-lattice rectum, you take half of that, endpoints of lattice rectum, then even equation of lattice rectum we study. Prepare all these things. So based on that, sums I will teach in the next video.